Les is gently
So whatever this
sculpting
weighs, that's
the
where
sample
I'll
with the
look
string
around
to
for
come
that.
up
That's
with
what
4 flat
Right.
surfaces.
So
Our
that would
sample
be
is
about as much as
relatively
this
dry
weighs.
and somewhat
Okay.
crumbly.
So
This
basically, I'm
attempt
looking at
may
most of
lead
those.
to our having to re-wet and mold the sample over, but we're just going to continue on here and see what we get. He's like an artiste. Direct pressure, sawing motion. He's just about done, and in my estimation, at this point, we're looking at remolding. Okay, we can edit that out, right?
Here you go.
And albeit this might get a little bit odd, you're not going to penetrate much.
Now we're watching for deformation along the sides.
You can do it off of any number.
It's a visual perception.
Notice right there, now that's going up. Now this is not moving because it's pushing on it. Yeah. But if I had it in there, this is going to move.
You see the gauges moving as he's increasing
your,
the pressure with the dial. No deformation at this point. You see a stress crack on the right.
So when you're setting this up, this will be like right at the top of the soil.
Yeah,
and
then
that will be.
Yeah, you
Is that 50,000 we've won so far?
You got to seat it.
Yes, so.
Typically, you're going to seat to get kind of going, and then you start from there.
That's why that reads in thousands.
I don't know.
We may have to check the gauge value.
Let me go look at a couple
Could be
more
thousands.
molds, kind of get the general stick on
Crack
this.
is growing
We can
larger.
come back
Crack?
into
Oh,
this.
I
can't
think
do
we
it.
have
I've got a
deformation.
load ring. It's
What
in
would
the
truly
drawer.
constitute a failure, I'm not sure of.
That's showing what this
How
is.
can you get the crack?
In other words, that's
She's going back down.
This only measures.
As you
And-
can see
oh,
the
there we go.
separation.
10,000ths of an inch. See that little thing? Each one of those is 10. See that .0001, right?
Yep, now it's going back up.
Yeah. Yeah.
So we hit the
Ones, tens, hundreds, thousands. No. Tenths, hundreds, thousands.
This has got a .200 range, so that would be
Yeah, tenths, hundreds, thousands, 10,000s. This is
0.200?
measuring 10,000s. This is measuring in thousands.
Thousands.
Okay.
so.
Thousands of an inch, right? We use standard units of feet, but sometimes you can whatever. So that's that. And
Are you
so
getting
that
tired
you
yet?
kind of get an idea what that penetration is to get this. And I can't remember which one is going faster. This is turning around a lot faster.
Ooh, the first
Oh,
piece
there
just
we
fell
go.
off.
That's total.
There it goes.
Ta-da!
Okay. All right, so that put it here though. If you want to get a slower rate. Okay. Let me see if I can get a. All right.
Boom. Back
Probably
to
you can use
zero.
sand as much as anything else for there.
Rolling.
Yeah, we'll let you free. You only have to have enough on here so you can see that it works within. Now, will they fit inside of that is my question. Yeah, I think they do. That's certain. Right, so pull that one off. So I'll try
One full revolution right there.
One full revolution.
Right, so
That
we kinda
equates to
get-
what?
10,000s. Or it's measured in
That's
10,000s.
close enough. Now that's.
Yes.
I hope that it'll. So you're just trying to get that concept.
Sample
Watching.
looks good. There's no stress cracks yet.
And are you watching the height or
This
the
one I don't think
sides?
is machined
Yes, we're
around.
watching the height.
Okay.
Yeah, for the most part. Yeah. Right. So you
And
just
if
get
you
that
see a
general
Two
visible-
revolutions.
And the kind of things
If
you
you
can
see
do
a
is you can
visible
show
crack, what does
this.
that represent?
I think fundamentally on this test you could show it.
There
this
is
works,
a little small
pushing
crack at
through
the
sand
base,
with no
but
contaminant.
no
In other words,
apparent
you put the sand
cracks
there with none of this
in the
stuff,
sample
it'll go
itself.
right down through it. Why? Because of that equation. C, sand is cohesionless. Sand does not have any cohesion. Plus overburden times the tangent of phi. And go with friction. Now, if you have overburden,
We've
which is
traveled
this,
so far
then you can see how much stronger it gets.
roughly a
Yeah,
quarter
makes
of an
sense. I think
inch.
that's fundamentally.
And how many revolutions?
Kind of that equation.
This will be 3
This-
revolutions
the
right now.
more the angular interlock is,
Taking
Starting
the-
to see a crack
that's the tangent of the angle.
come from the
Tangent
bottom.
45,
Seems to be the only visible crack at the moment.
square root of 3. So now we're moving up that circle, right? What's the tangent of 30? 1 over square root of 3. And then eventually,
Do we have a true failure mode, or is this just a pressure test?
You don't get, you can look at normal range of these soils, you don't get much above 42, 45 degrees. Friction. You haven't looked
Crack
at
is
friction
growing
yet, but
larger.
Friction, basically, the angle of
There's one
friction,
small
if you put
crack on the
something
back side
on a board,
behind
angle of
the
friction between
travel
the movement is
indicator
actually
gauge.
the angle at which the thing starts to slide. It's based on other math, but remember that from high school? Maybe, yeah.
Do you need to
And that-
watch
it's
these
the same thing.
gauges when they
It's
go
a Very
backwards?
similar thing, but it's not.
'Cause every now and then they
exactly. It's always
tend to
something.
slip back.
So,
I don't know if that's an
concepts
indication
again.
of failure.
That's when I
haven't done this. Which way does
are
gravity
not
go?
consistent on the crank.
Down. Which way does the normal?
That's 4
force?
revolutions.
Perpendicular to the point of contact. Right. So what you see here is you
Sample
can
really
see
has a
that
crack
this
on
is
the
for
front
every
side
action, there's equal
and a
opposite
visible
reaction.
crack on the back side.
Again, somewhat within
wish I could
SketchUp,
light
though I
that
don't think you have
somehow.
enough time. Think about all those little sand grains. You could draft a sand grain at a millimeter, and then you could copy it, and you could stick it, and
Oh,
you know,
nice
that's
job.
the kind of thing that I showed that sketch of physics. I want to show you. It's not perfect, but it'll do those types of things. You can just fill this up with balls.
Wow, you're losing a lot
That
of
general fit.
size.
So you might, when you're done doing this shot, you might still try a little.
We're
bit
down
of
to a half
that.
of inch
I'll
of
show you
travel
real
so
quick,
far.
The drafting that you got. We'll see whether they get installed in the machine.
It's starting to look a lot like a pumpkin from a cylinder.
It's this that I
Ooh,
want you
pumpkin
guys
chunkin'.
who saw it, especially those who've had CAD, and those who will be very
Thing
good
would
at
be
CAD.
should be going backwards pretty
Because
soon,
now
I
it's
would
in the
think.
world a little bit,
Having some breakage on
Why
the
would you
back
not
side.
Calculate it and use a CAD at the same time. I mean, you got Ruby sitting right there. AutoCAD's the same, right? And it's not even the formal bit. It is and it isn't. But I guarantee you that work for Revit, all this 3D work is out there, and it's not what you want to do, but it's part of it. You got to be able to be good in an office to really get it really employable in the winter. You got to be able to come into the office and not just.
It's really starting to, what would that be, shear and
Over years.
shear is a
Strain.
big
And so that little bit. So it's the kind of the SketchUp thing. Even the timing is kind of good.
We're at about 3/4 of an inch of travel.
You don't want to have a goal in it, or you'll just get frustrated, right? You're just thinking around.
5 revolutions
It's not
now.
bad. You can kind of learn a lot. As soon as you try to do something, right, on deadline. Now that's why doing stuff in AutoCAD. Except the goal of bringing in text, and you saw the walking around. That's nothing, right? So one thing you can't do, but you can. I haven't had a chance to work on it. You could run.
A little inaccurate reading with our
I can't believe you haven't done it.
gauge
What you do,
properly
you bring in an
not,
image wave, so you bring it in
adjusted.
there, just like your image. You can write a script that says bring in this image, bring in another one, bring in another one.
We're going to recalibrate and test again.
All right, yeah, that's pretty
Yeah.
straightforward. So you
But I
gotta
think we
get
really
that
got some
bit.
good footage here.
So you
The
got
pumpkin
you
is
kinda-
growing
do you wanna
larger.
think you get some sand in here or something right now, or whatever. I'll just give it a try. You can
The
understand
cracks
you're
on this
there
side are phenomenal. Your
for
side
what
too,
you
Bart?
kind of need to do.
Well, I've got a pretty good size one
Get
here.
a sense of what
We're
thing
getting
you
a little
get the
debris
width
to
of this
start
thing right
falling
now.
off.
At the weight, which and don't have a border on it. What you want to do
Yeah,
is
these are
this is
opening
the
up
best
here.
I got. And I don't really want to do more than this right now. This actually got tweaked out. I don't want to adjust it now. But does it look like it's a little out of true? Yeah. Okay, good. So we got to adjust that next semester. But, this spring, I'll find it by next time, so you don't have to do it. But you could actually. Look at this. Sometimes.
You get lucky.
I think it's in my.
We went around 6
So,
revolutions
taxes and insurance.
and
All right.
have traveled just about an inch. A lot of rotations on this
So
small
there
little
is
wheel.
a. Look at here.
Small chunks are starting to fall off the back.
Oh, there's one. I would think you'd tend to see it go anytime soon.
So there is a
Are you
proven.
tired of cranking?
I'll get it. You don't have to. But otherwise, what you would do if you don't have
She's
it,
close.
you would turn it upside down or whatever, and just start putting forces and weights on it. Because when I picked it up, how high did it go? So it's a 1-to-1 ratio. This is pretty much a straight line. So in other words, it's like a fish spring.
That last sample was
F equals
actually a very
KX.
good one as far as moisture goes.
This one?
Held together very well.
Distance of motion. So this essentially measures
This is a
force, and this measures
Sample
movement.
from the
And what
field
you're
trip
doing
to
is you're
Kaylee's
trying to
farm.
compare how this thing moves through the soil.
It's still really solid. As you can see, there's nothing really flaking
So
off.
you might want to figure that one out. You could do that. You could figure out what your cadence is to get that.
The clay is dirt is
Yeah, there's.
under a lot of strain.
Yeah, so.
0.01 and 0.02.
Yeah. So you can just figure out, how much it moves in a revolution. That would be a good use of 10 minutes, really. In other words, you can figure out, by putting something in there and move this thing up, see how many revolutions it measures.
It's like you're running a lathe.
Yeah.
Yeah.
Kind of get that bit of the. Bruce is probably over there.
Okay, I think we're at our maximum limit now. Still pretty firm.
Do you need some taken off the top for travel? Do you need that top loosened up for more travel?
I'm sure
'Cause
we're
I
fine.
could give you some more room, I believe. Oh my gosh.
No, I
I'm not
was gonna
moving
say that's
that.
all that pressure is pushing that up.
Equal and opposite.
No, this was the bottom one.
I don't think this is gonna crumple. I already starting to see it mushroom up around the
It's coming up over the...
very, very strong.
You see it's coming up over the top here. By a substantial amount, too.
It's like your brain on drugs.
Especially on the back side.
Well, and underneath here too.
What have you
Yeah.
got for a height now?
Yeah, it's pretty crazy.
About 1.5, maybe.
So we want an inch and a half.
I suppose we should turn that into survey feet. This has got to go off the back. I mean, the
I know,
bass
it's hanging. Maybe a good camera angle off the back. If you could see the,
it's going to go.
it looks like a
There it went.
mudslide falling.
Did you get it?
Yeah, I got it.
Cool.
Yeah. I would say.
I think that's probably good
I think
enough.
that's about it.
Cut. Sample started at 3 inches in height. It's compacted now to roughly 1.5 inches. There was some mushrooming around the top surface where it kind of ballooned over the sides. Barb got some footage of a large chunk falling off the back. But all in all, this was relatively strong soil for the sample that we have.